Hello students, today we'll be discussing about the JEE mains paper that was conducted in 2017. So here onwards we'll be discussing all the 30 questions one by one, the concepts and the tricks to solve the questions of JEE 2017 mains physics paper. Okay. The next question is it is about radioactivity decay. So it is about decay law that a radioactive substance or nucleus A with a half-life T. So there is a substance A with a half-life T decays into a nucleus B. So A becomes B. Okay, this A decays to B. At time T equals to 0, so at the time T equals to 0, there is no nucleus of B. That means at time T equals to 0, here the number of nucleus here is 0, B is 0, and suppose that initially its total number of nucleus is n naught. At some time, after some time, what will happen? After time T equals to T, say, the ratio of number of B to that of A. That means after some time some part of some nucleus will decay to B. So I'll say that the number of nucleus present here is NB, and the nucleus that is present here is Na. Okay, but then definitely Na plus Nb must be equal to N naught. There is no doubt about that. And it says that the ratio of the number of T, the ratio of number of B to that of A is 0.3. It says that number of B molecules of B or nucleus of B to that of A is 0.3. From here I'll write NB equals to 0.3 Na. So NB is this. So out of this N naught, left is this is the amount that is present, and whatever is decayed is in B. So NB is 0.3 Na. So in place of this I will write 0.3 Na because I got NB as 0.3 Na, and here it is Na. So that means what? Initially it was N naught at time T equals to 0, and this is reduced to Na, and the left part is reduced to 0. The rest is converted to B. So that means this plus this must be equal to N naught, because original value must be equal to the decayed value plus the present value. So from here I write N naught equals to Na plus 0.3 Na. You got this point? That whatever is present is now converted to, now some part is Na and the remaining part is converted to B, because from one molecule that is converted to another molecule, that one nucleus is converted to another nucleus. So this is the situation. So at any time the total number of nucleus must be constant, that must be equal to N naught, out of which this is Nb and this is Na. So from this I will get the equation that 1.3 Na is N naught. Okay, now initially, so I got N naught in terms of 1.3 Na. Now the question is to find that this happens in time T. So I have to find the time. How to find the time? So we have one equation to find the time. That equation is N equals to N naught e raised to minus lambda into T. This is the equation of to find the number of molecules present, or the nucleus that is present at any instant. This is the amount that is present nucleus. That is the nucleus that survive after time T. So this is the amount of nucleus that is present. So this is I'll use for the molecule number nucleus 1, then I'll write that this Na that is present for about A, I'm writing about this A, I'll write that Na is present, and initially it is N0. N0 is in terms of Na that I have calculated, it is 1.3 Na e raised to minus lambda t. So originally it was this, now it is this. After what time? This is the situation. This is the time that is asked in the question. So then I can do one thing, I will cancel this Na, and 1.3 is brought down to this side, or e minus lambda t, that is brought to the other side. So what I will write from here, e raised to lambda t equals to 1.3, because Na will cancel out. If I take log both sides of the equation, then taking log, this is lambda t log of, this is base e equals to log of 1.3. So from here, lambda t comes out to be log of 1.3 divided by log of 2, and from t here, t equals to log of 1.3 divided by log of 2 divided by lambda. But if you see the options, there is no lambda here. So that means you have to use in terms of t. So how to write in terms of t? Because we know that the half-life is 0.693 divided by lambda. This is actually log 2 by lambda. So 1 by lambda can be written as, I'll write this as 1 by lambda, or lambda I'll write log 2 divided by t. I substitute here, this will be t log of 1.3 divided by log 3 log 1.3, the t comes out, log 2 is there, lambda is log 2 divided by t, this is log 2, okay, and then log 2 here lambda t. Okay, there is one mistake over here. The mistake is that if you take log, this will become e, okay, that is 1. So this become, it's okay, that is, this is e, this is basically e, and that is 1, this is e, and that is 1. So this will become 1. So the answer is t. So this is e, this is t log of 1.3 divided by log of 2. Okay, so you can see here, by taking logarithm, this will log both sides, this is lambda t log of e, not 2, log of e, and that is 1. So I should have kept it 1 earlier, but it's okay, log e is 1, so put it 1. This is the final result. You should see the option, then t log of 1.3 divided by log 2, t log of 1.3 divided by log 2. So this is the correct answer. Okay, thank you.